Chapter 3, Software, Part 2. Perpetual licenses allow the customer to install the software on his computer and use it indefinitely, forever. Of course, no company is ever going to commit to providing technical support forever. So the technical support will be limited to a fixed term. If the owner of a computer has a perpetual license and has installed the software on his computer, when a buyer gets the new computer, he gets the software that was on the computer and any restrictions that the previous owner had acquired. The purchaser can't go ahead and copy that software onto other computers, and he cannot distribute copies to his friends. Subscription licenses, becoming more and more popular, allow the user to use the software for a specified period of time. As I said, they're becoming more and more popular. Microsoft Office 365 is software that is typically sold as subscription. Subscription licenses usually include technical support for the period covered by the subscription and will support upgrades and patches that are released during the term of the subscription. By the end of the term, the user has three options. He can renew the subscription, can purchase a perpetual license for the subscriptions for the software. The company will often provide the perpetual license at a discount for people who have been on a subscription basis, or they can remove the software from the computer. During the 1980s, several software developers didn't really have the money to set up advertising campaigns, so they developed another system for marketing their programs. They would distribute free copies of the programs and recommend that the people they gave them to copy them and give them to their friends and family, anybody they knew who might be interested in that kind of thing. They suggested, didn't have any way of requiring, but suggested that the people who are using them, the programs, if they liked them and wanted to continue using them, that they might send some kind of payment to the authors. This system of distributing and marketing software, recommending users share the software with their friends and requesting a payment if the users like them, come to be known as shareware. Another system of development, freeware, refers to software that's provided free of charge. It can be used without paying for it, but generally is proprietary software, and modifying, redistributing it, and reverse engineering is generally prohibited. Two well-known examples of freeware are Skype and Adobe Acrobat Reader. Freeware, although it is provided free, they aren't charged for the program. It's usually intended to benefit the producer one way or another. And the source code is not available. You get the executable code, not the programming language code. Open source software, OSS, is computer software whose source code is released under a license where the copyright holder grants the users the rights to study, change, and redistribute the software. Open source software is very often developed collaboratively. Software as a service, SaaS, is a way of delivering access to central hosted applications as a service, using the internet to communicate. SaaS applications, sometimes called web-based software, on-demand software, hosted software. Whatever the name you use, SaaS application programs run on the provider's servers. Instead of installing and maintaining the software on the user's computers, the user just accesses the software using the internet. That way, the users don't have to worry about installation or management. The provider manages the access to the application, works on the security, the availability, and the performance. The business applications are usually accessed using just a web browser. Traditional software was conventionally and still is commonly sold as a perpetual license. There's an upfront cost, often optional, ongoing support fees. SaaS providers generally do price applications using subscription model, generally a monthly or annual fee. It's become the common delivery model for many business applications. The basic idea, centralized hosting of business application, actually goes back all the way to the 1960s. IBM and other mainframe providers sold and conducted service business referred to as time sharing or utility computing. These services provided computing power and database storage from their data centers. The services were marketed primarily to large organizations and to banks. As businesses and individuals began to acquire their own computers more commonly, this kind of service was kind of dropped out of favor, was less widely used until the expansion of the internet during the 1990s made communication easier and more reliable and brought about a new class of centralized computing, application service providers, ASPs. These ASPs provided businesses with a service of hosting and managing specialized business applications. They had the goal of reducing costs through central administration and through the solution provider's specialization in particular business applications. SaaS extends the idea of the ASP model, but there are some differences. While the ASPs focused on managing and hosting third-party software, the SaaS vendors started developing and managing their own software. The initial ASPs offered more traditional client-server applications that would provide installation of the software on users' personal computers. The SaaS solutions rely predominantly on the web, and their use normally only requires a simple web browser. Now, the ethical issues related to computer software can be divided into two categories. Ethical issues related to users of software on their computers, and ethical issues related to the providers, the distributors, and developers of the software. There are two contrasting issues, two contrasting views on one of the ethical issues for users, that of piracy. And both views have some valid points. There are people who believe that software piracy is ethical, and there are users who think that software piracy is unethical. Some people don't think there's anything wrong with software piracy. They believe in the freedom of information, freedom of expression, and that it is acceptable and ethical to copy the software because they have a right to the information contained in the software. And they believe that reproduction and distribution of software is for fair use within the copyright law, and that copyright piracy is a victimless crime. It isn't completely victimless, of course. It costs just about everybody. Since given piracy, many copies are pirated and copied and distributed, not as many copies of the software are sold legitimately. That means software manufacturers have to raise their prices to make the same profit to pay for their expenses. It means that legitimate users who actually buy their software have to pay higher costs because of the piracy. In short, piracy is not victimless, as seems at first. Software developers, distributors, and eventually all end users are hurt by piracy. The widespread use of computers has provided us with the possibility for new behaviors, and many of these new behaviors have the potential for being unethical. Because our computers give us the capacity for so many new unethical behaviors, they've given us a new level of insecurity. And with so many new ways that we can become victims of unethical behavior of others. Among these unethical behaviors that the computers in our lives support, identity theft, software piracy, cyberbullying, plagiarism, unauthorized access to private information, spreading of viruses, and secret monitoring of the activities of others. Given the widespread use of computers and especially smartphones by children, the situation has evolved to where parents now have the responsibility, for which they are generally quite unprepared, for preventing their children from engaging in or becoming victim to such unethical behaviors. Accepting unauthorized copies of software, allowing friends and associates to make copies of software that you have purchased, at the very best is questionable, ethically speaking, and legally it is illegal. Although bullying has always been a part of our lives, social networking has given would-be bullies enormously greater powers. There are a number of widely publicized incidents in which victims were driven to suicide. Clearly, parents of possible victims have a responsibility to protect their children, and the parents of potential bullies have a moral or ethical responsibility to monitor their children and prevent them from engaging in that kind of behavior. Documents of all kinds are widely available on the internet, as well as images and videos. Software for copying online documents and pasting them into other documents is widely available. And it's easy to forget that our ethical and legal duty is to attribute the source of what we're using. There's also a big industry of people who will write papers and do homework assignments for college students and high school students. Needless to say, submitting somebody else's work for your own is frowned on by teachers and editors everywhere and has to be considered an ethical violation, if not a legal one. Computer ethics also involve avoiding unauthorized access to computer systems and preserving the confidentiality and privacy of data in computers that we have access to. In addition, we have the responsibility for respecting system policies, not sharing passwords, and not trying to access unauthorized sites. This becomes a little controversial, of course, in the case of a parent accessing the memory and browser system of a child's computer or smartphone. It's not quite clear exactly how old the child has to be before it becomes improper for the parent to access the child's data. We know that harmful viruses do exist. So if we're going to share software with others, we have a responsibility to make sure that what we share is virus free, not harmful. In the area of activity monitoring, there are lots of ethical questions, but not all that many clear answers. Some employers will make it a practice to monitor their employees' activities while they're at work, even to the point of recording all of their email accesses. Now, a lot of people are going to argue that this is an invasion of privacy. Others argue, on the other hand, that the employer is paying for the employee's time and for the equipment that they're using and for the internet access that they're using. So you could argue that the employer has a right to make sure that the employees are using their equipment, access, and time for work-related activities. Whichever argument you believe, it certainly seems clear that secret monitoring of anybody's activities is ethically wrong. Or is it? Police do that regularly, don't they? When they're investigating suspected lawbreakers. Is it ethically permissible for the police to do it? Under what circumstances would it be ethically permissible for the police to do that? Should they be required to get a warrant? Parents do have not only a right, they have a responsibility to monitor the online activities of their children, or at least the activities of young children. At some point, the parents no longer have a right or responsibility. But at what age does this change? The simple fact that we have and use computers puts us at risk of a number of possible dangers, any or all of which should worry us. Among these dangers, identity theft, cyberbullying, getting hacked, virus infection, being secretly monitored by employers. Identity theft is the deliberate use of somebody else's identity. A person whose identity has been assumed might very well suffer adverse consequences because they'll be held responsible for the perpetrator's actions. Identity theft occurs when somebody uses another person's identification information, name, ID number, credit card number, using these without their permission. And usually it happens because they're going to commit some kind of a crime, including fraud. The majority of identity theft victims don't realize that they're victims until they encounter some negative impact. Many people don't find out that their identities have been stolen until some financial institution contacts them or they find suspicious activities in their bank accounts. According to Herb Weisbaum, everybody in the U.S. should assume that their personal information has been compromised. It's important to watch for early warning signs that your identity might have been compromised. Cyberbullying can be defined as aggressive, intentional act or behavior carried out by an individual or a group of individuals using electronic forms of contact repeatedly and over time against a victim who cannot easily defend himself. Cyberbullying is similar to traditional bullying, but there are some important distinctions. Victims of cyberbullying might not know who it is that's doing the bullying or why the bully is targeting them. The harassment can have wider reaching effects on the victim than traditional bullying. The content used to harass the victim can be spread and shared among many people, and it often remains accessible for a long time. The victim is also sometimes exposed to the harassment whenever they use technology, as opposed to traditional harassment where the bully has to be in physical proximity to the victim. Many people get hacked and don't even know that it happened until well after the fact. If you don't want to have your computer hacked, you have to be alert and stay vigilant. Watch for strange behavior in email messages, credit card statements, and generally watch for unusual computer behavior. Computer viruses currently cause billions of dollars worth of economic damage every year. Damage due to system failure, waste of resources, corruption of data, increased cost of maintenance, many other things. In response, an industry of antivirus software has cropped up selling or distributing free virus protection to users of various operating systems. No currently existing antivirus software can detect all the computer viruses. The coming new ones are coming too fast and frequently to keep up. But computer security researchers are continually searching for new ways to enable antivirus solutions for more effectively detect emerging viruses before they become widely distributed. Technology lets employers monitor many aspects of their employees' workplace activities. Employees tend to feel that this kind of monitoring is a violation of their privacy, but many types of monitoring are allowed. Almost everything you do with your office computer can be monitored. This kind of monitoring is virtually unregulated unless there is a company policy specifically stating otherwise, and maybe even if there is, your employer can listen, watch, and read just about any of your workplace communications. Courts have found that when employees are using the employer's equipment, expectation of privacy is very limited. The 10 Commandments of Computer Ethics. Thou shalt not use your computer to harm other people. Thou shalt not interfere with other people's computer work. Thou shalt not snoop around in other people's computer files. Thou shalt not use a computer to steal. Thou shalt not use a computer to bear false witness. Thou shalt not copy or use proprietary software that you haven't paid for. Thou shalt not use other people's computer resources without authorization or compensation. Thou shalt not appropriate other people's intellectual output. Thou shalt think about the social consequences of the program you are writing. or the system you are designing. Thou shalt always use a computer in ways that ensure consideration and respect for your fellow humans. There is software that's designed specifically to monitor activities on a computer. The most common kind is keyboard logging software. Families and business people use keyloggers to monitor network using frequently without the users knowing that they're being logged. A lot of these programs seem to be marketed to individuals looking for evidence of a cheating spouse. Surely, just suspicion of infidelity is not a sufficient ground for totally violating the privacy of an individual, is it? So, how ethical is the behavior of the people that are marketing this software? Software developers and vendors daily make decisions with moral and ethical consequences. These ethical quandaries have to be faced by developers every day, whether they realize that they're making these decisions or not. There really aren't any easy answers, partly because the very nature of program development is so abstract. To make things worse, business is linked into the computer technology so completely, it's difficult to balance the needs and motivations of all of the invested parties. The trick for the developers is to think past the current situation and anticipate every future utilization of the system they're working on. Easy, right? Now, of course, somebody has to create the programs, make the computers do what the computer users want them to. The people who create these programs are called programmers, and the process of creating the programs has evolved radically over time. The earliest computers were programmed by connecting physical wires and plug boards. This process would usually require several days, and the computer simply couldn't be used while this was going on. It was John von Neumann who designed a system where the different numerical codes identified different computer actions. The numerical codes could be stored in memory, and a processor would read the codes one after another and process the corresponding actions. Computers developed using this system are said to be using a von Neumann architecture. This system allows programmers to design their code sequences, their programs, offline, while the computer is being used to execute other programs. Copying a sequence of codes into computer memory is easier and faster than connecting physical wires and plug boards. So this system, the von Neumann architecture system, resulted in a drastic improvement in computer efficiency. The possibility of controlling the action of a computer by inserting numerical codes into its memory obviously improved the effectiveness of the computer, but writing long sequences of numerical codes in binary format, machine language programs, it's easy for people to make mistakes. And it's very difficult to locate and correct these kinds of mistakes. Because these kind of programs are getting more and more common, where they developed a system for using simple descriptive words instead of numerical codes for describing the computer operations. These descriptive words were called assembly language instructions, and programs written using these codes are called assembly language programs. Assembly language programs, of course, have to be translated into machine language programs, the numerical codes that the computers actually execute. And this translation was done by programs they developed, and the programs were called assemblers, which is why they called them assembly language instructions. Assembly languages allowed the development of longer and more complex programs and faster development. But an assembly language is designed for a specific kind of a machine. And so the assembly language programs can only be used on a specific kind of computer. In order to create programs that can be ported to different kinds of computers, they developed high-level programming languages. The high-level languages were also designed to reflect human thought processes instead of basic computer architectures. And this allowed programs to be written more easily, more quickly, and supporting programs that were more complex. The earliest computers were used primarily for calculating, and the earliest programming languages were evaluated essentially entirely on their ability to create programs that would execute fast. But as they became more common, programs got longer, more complicated. The time that was required to write and debug the programs became more important, a bigger part of the computer's work, and language designers started working on programming languages that would make writing the programs easier and more efficient. They started developing languages that would allow programs to be divided into subdivisions, blocks, functions, procedures, subroutines, other terms used for subdivisions of programs. And this supported subdividing the programs, supported an approach to software development called top-down programming. This approach makes it easier for teams of programmers to work together on a project. And for functions and procedures to be used in multiple programs once the function is programmed, designed, and checked for correctness. It could be used in many programs. As it became more common for teams of programmers to work together on programs, and the programs got to be more and more complex, requiring larger teams, another paradigm was developed that provided even better support for distributing the programming tasks. This paradigm was called object-oriented programming. Object-oriented programming, or OP, relies on the concepts of classes and objects to support the simplification of programs, writing them using reusable pieces of code. Classes are templates, descriptions of how reusable code sections should be structured. Individual sections of the programs are called objects. There are a lot of object-oriented programming languages, C++, Java, Python. Beginning in the 60s, they started recognizing that software development was much more problematic, much more difficult, much more complex than people had realized. It was difficult to keep up with the hardware, and this caused problems for software developers. Problems included software that came in over budget, exceeding deadlines, requiring extensive debugging, lots of maintenance, and generally failing to meet the needs of the consumers. Since many of the software developers had engineering backgrounds, it was natural to apply engineering techniques to the problem, and the resulting field of study was called software engineering. The use of the term engineering in this context is not without controversy. Many engineers don't really think software engineering is engineering, but the origin of the term seems to be due to Margaret Hamilton, who started using the term widely during her work on the Apollo program.